One last one here. 12, standing at the job site, watching the concrete coming out of the truck, I'm worried about the concrete being too runny or wet. Which test should I consider? So we have the Vane Shear Test, the Cylinder Test, the Slump Test, and the ACT Test. Well, first off, you should recognize the ACT Test is the test that high schoolers do, I believe. So that's not the right one. So it's definitely not D. So then we have these other three. A Vane Shear Test is actually a soils test, and that's one when I've got this little device that kind of fits in the ground. This is not a great drawing of it, but I think you get the idea, and it has a little handle on it. And you stick it down into the ground, and then you turn it. You try to make it go around. And what that's going to do is going to tell you what kind of soil it is. Like if it's a running soil, like if you can twist it easily, that means you're not going to get any horizontal capacity, anything that's going to stop your building from shifting horizontally if there's an earthquake or there's some other or hydrostatic issues that are going to push things one way or the other. So it's going to tell you what kind of soil that is, and it's a very useful thing to know in very specific situations, especially ones that are kind of have to do with retaining. But that's about soils. It's not about concrete at all. So that definitely is not it. So it's not A and it's not D. So we can definitely rule those guys out. So then the question is it B or C, cylinder test or slump test? So cylinder test, fairly straightforward. I have somebody is pouring concrete, and as they're pouring concrete out of the truck, you're gonna, off to the side, you're gonna have a little formwork that's a cylinder shape, and they're gonna pour a whole series of these little cylinders that are usually 12 inches tall. I think they're 6 inches in diameter, but I actually don't remember exactly. And you're going to make these cylinders, and you're going to make a bunch of them out of every truckload of concrete that comes. And then you're going to mark on it what the truck was, what delivery number it was, which batch of concrete it was, and then where that batch was being placed into the building. And you're going to make these little formwork pieces. You're going to put them into a storage area, and then you're going to let them cure, and then you're just going to let them sit there. And the reason that you're doing that is that you can then, at various points, say at the 7-day mark, maybe the 14-day mark, but definitely at the 28-day mark. 28 days is sort of the amount of time it's considered that concrete has fully cured. It actually technically doesn't cure fully until forever. It'll just keep curing, but it's so close to, like the way the curve works, at 28 days, you're very, very close to that. So it's just a sort of a workable number that makes everybody, makes it easy to kind of, it's 4 weeks from now, that's when it's cured. And so the idea here is that this concrete is the same concrete that got put into the building. You have a whole bunch of these. They're all labeled very carefully. And then at some point, there's a worry, there's a reason to think about it. You come into a device that smashes it, a big hydraulic press that presses in and checks the compressive capacity of that cylinder of concrete. And then by using the very particularly calibrated system, they can figure out what the capacity of the concrete was. And then you can say, yeah, that was what we ordered. We said we wanted 7,000 PSI concrete, and it came out to 7,000, or it came out to 7,500 or something. So that works just fine. Everything's good. You probably don't end up crushing them all. You probably just do ones along the way to kind of check to make sure everything's okay. Or if there was a problem, maybe you were very carefully organizing these things, and then you're crushing them right away, and you're going to check the one at 7 days, you're going to check one at 14 days because people are worried that there was a problem and you really want to check it out. But for a lot of the time, they would make these, do a few sample tests, because it actually costs money to crush these things. So you're probably not going to crush them all the time. And if you're doing a smaller project like a house or something, like a single family house, you're probably not even going to do the cylinders. But for any larger project, you absolutely should. It's probably part of the contracts. And it allows everybody to sort of check it out. But this is something, like if you're figuring out at 28 days that the concrete was bad that they put in, it's kind of too late. It's already after it's been done. And the problem is already done. It's already in there. So in the example that we're talking about here, he's looking at the thing, it's coming out of the concrete truck, and it looks too runny or wet. Like, if we claimed that the cylinder test was the thing to do here, that means we wouldn't figure it out until a month later. Well, that's not terribly helpful. That means you got to go back in. This is a month of construction that has kept on going. You have to go back in and rip it out if it's a problem. It's a big, big, big mess. So the actual answer on this is, of course, the slump test. And what that is I have this truncated cone, which is like a big cup. I fill it with the concrete. I then flip it over and I make that cone go the other direction. I take the cup off, this truncated cone off, and I see how much that shape slumps down. Literally, it's a slump test. I'm measuring the slump. And if I end up with a situation where it slumps down into like a little puddle, well, that's way too much water in that mix, and that's going to be a terrible, terrible concrete mix. If I take the cone off and it doesn't slump at all, it has a zero slump, it stays exactly in that same form, well, that might be useful for precast, but it's going to be almost impossible to use out on a job site in any complicated formwork or trying to get around the rebar and anything like that. So it's different for precast in a factory versus doing something on a job site. But typically what you're going to end up with is it's going to slump down, it's going to kind of go something, and you'll get somewhere in this kind of 3-inch range, maybe 4-inch range of slump. If for some reason you really don't need the compressive strength and there's reasons why you want it, you might even go as much as like 5-inch or something if you were on a job site and the slump was only like 1 inch or something, you might be able to get away with that in a simple scenario, but the vast majority of the time it's going to be something like a 3-inch slump. So that would tell you they do the slump test right there and then. If you get the puddle, you say to them, well, you don't say to them, but you say to the GC, hey, this isn't going to meet the thing. You guys should really not put this in because we're going to test all these cylinders, and they would know to stop the truck, send it back, get a new truck in that has a better mix, a better slump, and would be more effective. So that's the 12 questions, and I hope that what you're seeing is, as we're talking about these very specific elements, what we're really talking about is kind of these big ideas of water, workability, the process of how these things go, kind of means and methods, keeping things to be structurally sound, and those things end up being shown and the questions end up being asked through these very minute pieces, but in fact they're talking about these bigger issues.